right, Algebra 1, Lesson 4, and this one is on a ton of stuff. Lots of review. We're actually doing 10 different portions of review. That's why this is called Review of Arithmetic. Now, you may want to take this lesson and watch half of it and then watch another half of it maybe after you give yourself a 5-minute break. Because you're going to be reviewing 10 different things. You may find it easy and you may not need that, and that's fine. But whatever you need. Okay, the first one's pretty simple. Actually, the first two are very simple. We're talking about numerals and numbers. And so basically, we had to use something, a picture of some kind, to show what 6 pencils mean. So this picture means 6. Okay? This is another one that we see. It's Roman numerals, but it's a picture that means 3. And we get used to in our head that these mean certain things, and that's good. We can even do fractions. 33 over 11. That's still a picture. You know that that says 33 over 11 because you know that 2 sticks like this mean 11 and 2 swervy lines like that mean 3. So 33. Okay, just a quick little... pretty much a new number is an idea of symbols made. Okay? That was simple. Now, the only other thing I want to talk about that's pretty simple, this is the 4b, and this is the natural or counting numbers. Now, it naturally, when you start counting, you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You keep going. Those are called natural counting numbers. Comes natural. Whole numbers, okay, if this is a fraction, this is a whole number. So I have 5 whole pies and then 2/3 of another. So 5 whole and 2/3. So this would be considered a whole number. Now, the difference between whole numbers and counting numbers is just 0. 0 is not a natural counting number. So we wouldn't say, count to 10. You wouldn't say 0, 1, 2. You would say 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5, these are all whole numbers. If you just start counting 1, 2, 3, 4, 5, those are just called natural counting numbers. Okay? Just a review that they think is important. But anyway, counting numbers, whole numbers. Okay? Now, let's talk about real numbers. Okay? And I'm going to draw a few real numbers up here. And you may look at this and go, what? Those are real numbers? But I'll explain myself in just a minute. Okay, hopefully you can see those. Let's start with 3/4. Okay? A real number is a number... the best way I can explain it is that it eventually stops. Especially the decimal part, it stops. Irrational number is the opposite of a real number. And we'll talk about irrational. Pi is an irrational number because 3.14, literally a different number every time. And it will continue on forever, and there will continue to be different numbers. Whereas, look at this one. 400.16, and then I hope you see this pattern. 2323. That basically indicates, that little repeated mark right there, indicates that as you can see, this is going to continue. 23, 23, 23, 23, 23. So even though it's a decimal number, it actually stops because we can see that that's what the number is going to be. So that is a real number. This one stopped right here. We were done with the equation and got the answer 163.000163, and it stops. It didn't keep going on and on and on and on forever like pi. Okay? So these are all called real numbers. Alright? Just a quick little thing. And we may say 3/4 of a mile. We may say 163 millionths of a yard. We may say 363 feet. We may say 3 3/8 meters. They're just different. It doesn't really matter. But these are all real numbers is what that is stating. Now, let's talk about a positive and a negative number, okay? Positive, all real numbers will have an opposite. So, 7, positive 7, will have an opposite, negative 7. 3 and 3/8 will become 3, negative 3 and 3/8. Okay? So it always has a positive or a negative. Alright? These are the negative sign. When a number has no sign, it's known to be positive even if it doesn't state it. Okay? Just quick review. Alright? Now let's talk about a number line real quick. The 0 is called the origin, the place where you begin. Alright, now I'm just going to do a quick review on this. If you want to draw this on your paper, you can as well. Okay? Now, these aren't quite the right distance, but just stay with me, okay? If I told you to graph 1 1/2, 1 1/2. If I was going to graph that, well, I have 1 whole and then half. It's not, I haven't quite gotten to 2 wholes, it's 1 1/2. So this would be an example of 1 1/2, that blue dot right there. Alright? Now, what about negative 1/2? Okay? Negative 1 1/2. We don't go to negative 2 yet, but we go to negative 1/2. So this blue dot would be negative 1/2. See that? Alright, now let's try this. 3/4. Okay? It does not have any whole numbers, so you could consider that means 0 whole numbers, but it did move 3/4. So it does not move 1 yet. We've not even made it to 1 whole. We just made it to 3/4. So hopefully you can see that that's about 3/4 of the way. 3/4. If I did negative 3/4, then hopefully you see we didn't get to 1 yet. So we're going to go to 3/4 that way, and this would be negative 3/4. Hopefully you see that. All right. 2.6. Let's graph that one. 2.6 means 2 whole, okay? And then 0.6 is a little bit more than half because 5 would be half. So it's at least 2, but it did not make it to 3. It's 2 and something. So it's about right here. Now, I'm not looking for perfection, but I just want to show you that that's about 2.6. What about negative 2.6? Okay? Negative 1, it's definitely that much. Negative 2, it's definitely that much. But it's a little bit more than negative 2. It's not quite reached negative 3. So negative 2, a little bit more than halfway that way. So negative 2.6. You see how that works? Hopefully that's pretty self-explanatory. All right? Another way we say this is if I say 2, then the opposite of 2 would be negative 2. Okay? So 2, the opposite of 2 is negative 2. All right, now I'm going to use those terms in a minute to say the opposite of later on. Okay? So now we're moving into 4, the 5th part of the lesson that we're learning today of this. And they're wanting you to just review multiplying and dividing fractions. So let's do that. Let's just do a couple of these, okay? Here is an example. 4/3 times 7/5. Now, you just basically go 4 times 7 is 28, and 3 times 5 is 15, okay? Hopefully you remember from last year and the years before, 28 over 15, this is an improper number. Let's make it proper or into a mixed. So this would be 28 divided by 15. And that's what I would do. 28 divided by 15. And that's going to end up equaling, bring that 13 up and that 15 over, 1 and 13/15. Okay? Let's do another one. Okay, these are just quick reviews. This should be stuff you already know, so this should really be a review. What about this one? 4/3, and here's what they say, divided by 15 over 8. Now, hopefully you remember from years before that you cannot divide a fraction. You have to multiply. But if I change this division to a multiplication, then the number or the fraction to the right changes to its reciprocal. So this said 15/8, I'm going to make it 8 over 15. Hopefully you remember those rules. Okay, now it's just like what we did just a while ago. And we would go 4 times 8, 32. 15 times 3, 45. See that? Okay, and I don't think that will reduce anymore. Okay, so let's move to another one. Try this one. 7/3 times 30 over 9. Hopefully you remember canceling out. Instead of doing 7 times that big number, you can actually cross cancel. What I mean by that is look at this number and this number, or this one and this one, but right now we're looking at 30 and 3. Will a number go into both 30 and 3? Yes, 3 will go into both of them. So you're going to go in and go, okay, 3 will go into 3 one time, 3 will go into 30 10 times, and that becomes our new numbers that we can use. And 7 and 9, you can't reduce those because a number won't go into both of those. So now I'm going to go 7 times 10 is 70, and 9 times 1 is 9. Okay? And then when I find the mixed number of that, it ends up being 7 and 7/9 once I make that into a mixed number. Okay? Feel like you're getting it? Let's do one that has multiple cancellations. For example, 3/5 times 5/6 times 21 over 23. Now, any top can cancel out with any bottom. Okay, so the first one I see is this 5 and this 5. Will this 5 and this 5 go into each other? Yes, 5 will go into both of them one time. Okay, is there another one? I see another one. 3 and 6. A number will go into both 3 and 6. What? 3 will go into both of them. 3 will go into 3 one time. 3 will go into 6 two times. All right, is there anything else that'll cancel? I could even use this number with this one and vice versa, and it doesn't look like there will. So 1 times 1 times 21 equals 21, and 1 times 2 times 23 equals 46. And that is my final answer. Okay? All right, let's talk about mixed numbers. Now, if I'm moving too fast for you, just stop it, take a breather for a minute, and come back to this, okay? We're going to do mixed numbers. 2.5 times 5 1/3. Now, what I recommend you do on this is to make these into a proper improper fraction before you answer it. So, hopefully you'll remember to make this into an improper fraction. You go 2 times 2 equals 4, and 4 plus 1 equals 5. And then you just use your denominator that you had there. Times, now let's do this one. 5 times 3, 15. 15 plus 1, 16. And then again, you just use your denominator. Okay, now let's ask ourselves, will either any of these cancel? 5 and 3 will not, but 2 and 16 will. 2 will go into 16 8 times, 2 will go into 2 one time. Okay, and that's it. 5 times 8 is 40. 1 times 3 is 3. And then when I make that into a proper or mixed number, it ends up being 13 and 1/3. And I would just take 40 divided by 3 to get that. All right? Let's do another one. If you feel like you got it, you can skip ahead, fast forward if you need to, but I think you ought to look at this one first just to make sure. 12 1/3 divided by 2 1/6. Now, again, these always should be made into impropers and then worked. So, 12 times 3, 36, plus 1, 37 over 3, divided by 2 times 6, 12, 12 plus 1, 13 over 6. Now, remember you can't divide fractions, you have to multiply. Instead of this being 13 over 6, we're going to change it to 6 over 13. Okay? Now we ask ourselves, can we reduce or cancel? And we can. The 3 and the 6, 3 will go into 3 one time, 3 will go into 6 two times. Okay? And this doesn't look like it will answer. So if I answered this, it would end up being 74 over 13. And then when I take 74 divided by 13, I get 5 9/13 as my answer. Okay? But what if you see a problem like this? And this may look confusing to you, but it's really not. 3 1/3 divided by 2 1/5. I recommend you taking this and writing it out sideways. It's easier for our brain on things like this. So I just write 3 1/3 divided by 2 1/5. And then you work it like I was asking you to earlier. You'll find the improper fraction. 3 times 3 is 9, plus 1 is 10. 10/3 divided by 5 times 2 is 10, plus 1 is 11. 11/5. I would change this to multiply. 11/5 would become 5 over 11. And then I ask myself, will those reduce? And they will not. So you'll get 50 over 33. And then 50 over 33, once you work that out, 50 divided by 33, you would get 1/17 over 33. All right? Just a quick review. All right? Now let's move to the F, 4F. This is still lesson 4. I think the 6th or 7th one. All right? This one's on symbols of equality and inequality. Basically, 5 plus 2, what's that going to equal? 7. So this equal means that it's equal. So this over here is the same thing as this over here. 5 plus 2 is 7, which is 7. So this just means the same as what's over here is the same as what's over here. If you see this, that means it's not equal. So for an example, 5 plus 3 does not equal 7. 5 plus 3 is 8, and 8 does not equal 7. Just a quick review. Okay, the next one, 4G, basic operations. We're basically going to take adding, subtracting, multiplying, and dividing. And I just want to review a few of the terms, the terminology. Again, if you need to take a break, go ahead and then start me back up in a minute. Now, let's talk about adding. 2 plus 3 equals 5. These are called add-ins. Add-in, add-in. This is called the sum. If you don't know that, you need to know that. Add-ins, sum. Let's talk about subtraction. For example, 9 minus 5 equals 4. Okay? These, 9 is the minuend. 5 is the subtrahend. And 4 is the difference. That's the answer to a subtraction problem. The difference. That's what it's called. If it says find the difference between this and this, they're asking you to find the difference of two numbers, to subtract them. Okay? This always helps me. The one that's being taken away, minus 5, that's the one that's being subtracted. It's called the subtrahend. The one that's being minused from, you're minusing from that. It's called the minuend. That just helps me. Okay? Sum, difference. You need to know both. Let's do multiplication. Sometimes you'll see a problem like this. 4 times 3 equals 12. You may see 4 times 3 with an x equals 12. You may see 4 by 3 like that in parentheses. That equals 12. You may even see both of them in parentheses. That means, again, you're going to multiply. So all of these mean the same thing, that you are going to multiply to get 12. Okay? Now, this first number, or even both of them, these are called factors. Factor, factor. And this is called the product. If I tell you to find the product of 5 and 4, that means they want you to know the answer to a multiplication of 5 and 4. 5 times 4 is 20. So, you need to know that product is the answer to a multiplication problem. And the numbers that you're using to multiply are called factors. And lastly, 10 divided by 5 equals 2. You may also see it 10 divided by 5 equals 2. You may also see it 10 divided by 5 equals 2. This is probably the easiest form for our brains to get, because we're used to working with numbers like that, especially as long division, okay? And even simple division. All right? So, this number on top, the answer, is called the quotient. If you don't know that, you need to. The answer to a division problem is called the quotient. Okay? The one right here, the first one mentioned, the one on top, the first one, or the inside, this is called the dividend. And it's best or easiest explained because it's on the inside, the dividend, inside. That's what it helps me to remember. Okay? And the one right here, this is called the, sorry about that train. This is called the divisor, the one that you're using to divide by. I'm taking 10 and dividing it by 5. It's called the divisor. The one on the inside, dividend. Okay? And then, you need to know that that is the denominator and this is the numerator. Okay? Just a quick review. They're wanting to make sure that you're understanding all those things. Okay? Alrighty. Now, quick review on decimal numbers when you're adding them or multiplying, subtracting, dividing them. Let's do a quick review of those. If I had 1.005 and they're wanting me to add 300.012, how am I going to line that up? Hopefully you remember that you line up the decimals when you add or subtract. So I'm just going to take that number and I'm going to bring everything down to line up my decimal. See that? And I'm adding. So if you want to, if it helps you to add 2 zeros right there, go for it. Okay? Now you're just going to add these up. Okay? 301.017. Okay? That's how we would work that. Alright, let's do a subtraction. Here's what it says. Subtract 0.02163 from 4.0016. So they're wanting me to subtract a number from another number. So they're wanting me to subtract it from this number. So if it's coming from this one, it goes on top. So I'm subtracting, and again, you want to line up your decimals. Okay, this number we're subtracting this number from the 4 number. Now, again, if there's not a number here, you've got to put something up there, especially on subtraction problems. Go in and add your 0 right there. That will help you. Okay? So, we work this problem just like normal. You would cross everything out and work that. And I'm not going to do that since it's simple math. It ends up being 3.97997. Okay? So that's just how you would do that. All right, let's talk about multiplying numbers. All right, 4.06 times 0.016. Now, hopefully you remember that you do not line up decimals when you're multiplying them. Okay, you're just going to line up the numbers. Okay, and what I mean by that is, I'm going to take and put the biggest number. There's 4 numbers here and there's 3 here. I'm going to put the biggest number on top just because it's simpler to work that way. 406, 406, and the dot goes here. You are not lining up decimals. Hopefully you see that. I'm just lining up numbers. And then you're multiplying just like normal when you're working numbers. And this one's going to end up being 694600. Okay? And because there's 1, 2, 3, 4, 5 spaces or numbers after the decimal, we're going to do the same thing. 1, 2, 3, 4, 5. You're going to start at the right and go 1, 2, 3, 4, 5. Answer is 0.06496. Hopefully you remember that and all that as well. Okay? And lastly, on this 4H part, we're going to divide decimals. So we're going to take the number 6.039 and divide it by 0.03. Hopefully you remember that you always need to divide by, the divisor needs to be a whole number. So if I went 1, 2 here to make this a whole number 3, then I'm going to go 1, 2 here, and that's where I'm going to keep my decimal. Now I have 3 will go into this number, and I'm going to hopefully you remember to take your decimal and bring it up. And then if I were to go into all of this and work it all out, I'm going to end up getting 201.3. Okay? And that is just, hopefully you remember how to divide. Alright? We're just working with the decimal. Now, 4i. We're almost done. We just have 4j to go. 4i is we're learning about unit multipliers. Now, let's talk about some unit multipliers. 12 inches is the same thing as 1 foot. For me to make unit multipliers on this, it would be 12 inches over 1 foot. That's the same thing. Or 1 foot is the same thing as 12 inches. These are called unit multipliers. You can also do it with any other that equals the same thing. For example, 3 feet equals 1 yard. So 3 feet, same thing as 1 yard. And 1 yard is the same thing as 3 feet. These are called unit multipliers. Okay? Hopefully you understand that. Alright, let's talk about converting lengths. Now, there's about 6 different examples in these conversions, part J. Okay? And so, each one builds on another, so you don't want to skip past them because there is important stuff in each one of them. The first one they want us to do is to use one unit multiplier to convert 32 feet to inches. So, the problem is, convert 32 feet into inches. Okay, now, the first thing you want to ask yourself, what are the 2 measurements I'm looking at? Feet and inches. And then you want to ask yourself, how many feet are in an inch or how many inches are in a feet, okay? Or foot. And so what you're going to do is go 12 inches are in 1 foot. That's the known unit multiplier for feet and inches, okay? So 12 inches equals a foot and 1 foot equals 12 inches, okay? Now, if I'm going to convert this 32 feet to inches, because I am converting it 2 inches, I'm going to use the one that has the inches on top. I'm converting this feet into inches. And because inches on top, that's the one I'm going to use. So watch what I do. I erase this unit multiplier because we don't need it. We need this one. And I'm going to take 32 feet, and you're going to multiply it by this unit multiplier. 12 inches over 1 foot. Okay? Now, as you can see, this has a top, and then this one has a numerator and denominator. You can go on and put this over 1 to help you out. Hopefully you remember this. This is just review. Okay? And hopefully you also remember that just as we could cancel out numbers, I can also cancel out, see those 2 feet? Feet and feet? Those cancel out. So now I say 32 times 12 inches. And 32 times 12 inches is, oh, it doesn't even tell me. They just say 32 times 12. So let's do that real quick. 4, 6, 2, 3, 8. 384. So, 384 inches. And then we went 1 times 1 is 1, which doesn't matter. So, 384 inches is the answer. So, how much is 32 feet put into inches? 384 inches. Got it? Alright, let's do another one. Remember, it gets harder each time, so it's important to pay attention to each one. Here's what it says. Use one unit multiplier to convert 36 feet to miles. Now, you may not know feet to miles, and so they give you a clue that 5,280 feet is the same thing as 1 mile. So, if I was going to write a unit multiplier for this, I would say 5,280 feet is the same thing as 1 mile. And 1 mile is the same thing as 5,280 feet. Okay? Now, I've written my 2 unit multipliers right there, but they're only wanting me to use 1, because if I'm converting feet to miles, which one do I want to use? This one or this one? Hopefully you remember, because we're converting 2 miles, we're looking for the one that's on top. Okay? So we're going to use this one. I'm going to erase this one. Now you're going to take the amount that you know, 36 feet, and multiply it by the unit multiplier. 1 mile equals the same thing as that. Okay, now remember, you're going to put it over 1. Alright? And then when you multiply this out, you're going to end up getting 36 over 36 times 1. Oh, one thing I did want to mention, you can cross it going out and cross out your feet. Remember that? These will cross. This mile doesn't cross out with this over here because there's not another mile right here. So that's just mile. It stays there. So 36 times 1 mile is 36 miles over 5,280. Now, this is miles. 36 over 5,280. And then when you did the math, if I was to take 36 and divide it by that, it would end up equaling 0.0068 miles. Okay? So, 10th, 100,000, 10,000. So this would be 68 10,000ths of a mile. That's how you would say that. Okay? Again, it's going to get a little bit harder. Alright, it tells me to convert 47.25 inches. They want to convert it to centimeters. Now again, you may not know that how many inches are in centimeters or how many centimeters are an inch, but they tell us that 1 inch is the same thing as, okay, so as I was saying, is that 1 inch is 2.54 centimeters. So to do this, we would say 1 inch is the same thing as 2.54 centimeters, and 2.54 centimeters is 1 inch. That's the way we would create our unit multipliers. Now, what we're going to do is they want to take 47.25 inches and they want to change it to centimeters. So, we want the centimeters on top. Now, so we will not need this one. And we're going to take the amount that we're wanting to convert to centimeters and write it down and multiply that by this unit multiplier. And let's go on and put this over 1. And I'm going to put inches right there since it's 47.25 inches. Now remember, you can cross out your inches. And now we're going to multiply 47.25 times 2.54. And the final answer for that, gosh, they're not giving us the final answers. Anyway, you would just multiply that times that, and whatever you would get, it would be that answer, centimeters. Okay? Now, let's move on to 4.8. We got a few more and we'll be done. Okay? Now, here's what it says. Use 1 unit multiplier to convert 42 meters to centimeters. Okay, now, I don't know if you know how many meters are in centimeters or centimeters are in meters, but it's 1 meter is the same thing as 100 centimeters. 100 centimeters is the same thing as 1 meter. Those are my unit multipliers that I wrote. Now, again, check to see what you're changing it to. We're changing it to centimeters, so we want that one to be on top. So this is the one we're going to use. Okay, so I take 42 meters and multiply it times this unit multiplier. Again, we put it over 1 and we cross out our meters and we end up getting, this one's actually an easy one, 4,200, and then centimeters is what's left because I've marked out the meters. So 4,200 centimeters. Alright, let's go on and do 4.9. Here's what it says. Use 2 unit multipliers. Now that's important, and you're going to see why in just a minute. And they want us to convert 4 miles. They want us to convert 42. That's the next one. Let's do this one first. 4.9 is 42 feet. 42 feet, and they want us to convert it to centimeters. Now, as I said earlier, this one says use 2 unit multipliers. Now, the reason why they are saying that is because we don't have a feet to centimeters amount. We know how to go from feet to inches, and then inches to centimeters, right? So that's exactly what we're going to have to do. We're going to go from feet to inches and then inches to centimeters. Now, let's do feet to inches. What are our feet to our inches unit multipliers? We know that 12 inches is the same thing as 1 foot, and 1 foot is the same thing as 12 inches. Now, because I'm wanting to take 42 feet and change it into inches, I want to change it into inches first. And remember, whatever you're wanting to change it to is the one you want to work with. That one needs to be on the top. So, we're not going to use this unit multiplier at all. So, I'm going to take 42 feet and multiply it by this. So, let me line that up. 42 feet times 12 inches over 1 foot. Okay, I'm just going to put this over 1. Alright, so remember feet and feet cross out. And so then I get 42 times 12, which is, let's do the math real quick. 504. 504, and then inches is left over. Inches. Okay? So now I've got 504 inches that I'm wanting to convert into what? Centimeters. So, again, I'm going to write this 504 inches. We're done with feet. Okay? And we're trying to convert 504 inches to centimeters. So, what are our inches to centimeters? You may have to look back. It's not a well-known one. So, 1 inch is the same thing as 2.54 centimeters. And 2.54 centimeters is the same thing as 1 inch. Which one are we going to use? Well, we're wanting to convert it to centimeters. So we always use the one that's centimeters is on top. Okay? So we don't need this one. So I'm going to take 504 inches times this unit multiplier. And we're going to put that over 1. And remember, the inches cross out. And then we're just going to multiply 504 times 2.54. And I'm not sure what that answer would be. In the book, just states it as showing that it multiplied 5.4 times 2.54 centimeters. That's the answer. That's how they leave it. Okay? But go on and answer, go on and answer that out, and then it would be centimeters, since that's how we're answering in the final, because we crossed out our inches. Okay? Now, very last one, and this is 4.10. It says use 2 unit multipliers to convert 4 miles to inches. Now again, the reason why they said to use 2 unit multipliers on this one is because we need to go to miles to feet and then feet to inches. You can't just figure out how many miles there are in inches or inches in miles. There's not a conversion for that. So we're going to go from miles to feet and feet to inches. Okay? That's how we're making our progression. And that's why there's 2 unit multipliers. Okay? So let's start with miles to feet. And we need to know the unit multipliers for miles to feet. And that is 5,280 feet in 1 mile. And 1 mile is 5,280 feet. I've written my 2 unit multipliers. Alright, now which one am I going to use? Well, I'm going to miles to feet, so I want it to be answered in feet. So I want the one that's feet on top. So I do not need this one at all. So let me move this over. 5,280 feet. Same thing as 1 mile. Now, we're changing 4 miles, timesing it by that. So I'm going to put this over 1. Miles and miles crosses out. And then we're going to go 4 times this. And I bet the book's not going to have that in. No. Okay. And so whatever that answer is, it's in feet. So 4 times 5,280 feet. That's our answer. Whatever that is. But we're not done yet because we've just converted it into feet. Now let's take this 4 times 5,280. times 4. And now we're wanting to convert it into inches because it's in feet. So, what are our unit multipliers from feet to inches? 12 inches is 1 foot, and 1 foot is 12 inches. Okay? And because we're changing it and finalizing it into inches, we want inches on top. See that? So that's the one we're going to use. 12 inches, 1 foot. Okay? So I'm going to take this 4 times 5,280 feet. I don't know what that answer is. I don't have my calculator with me either. Over 1. And see the feet cross out. And so then this is 4 times this, and that's actually how the book leaves it. 4 times 5,280 times 12. And because it's in inches, it's in inches. And that's it. To me, it makes more sense to go in and multiply them and figure out the final. But the book does not do it like that. So, anyway, that is conversions of length. Tons of different things you learned for a review. So, hopefully that was helpful. That is lesson 4.